big country. There is a good argument for 2 or 3 time zones, two at least, right?
Our people on YouTube are getting like halfway into this conversation. They're like, what are they talking about? I thought this was about computer vision. Yes, please, folks, as you join us on Twitch, on YouTube, on LinkedIn, say hi. Let us know where you're coming from. I see here on the Zoom, we've got Bremen, Germany, Miguel from
Uh,
California. We've got London, UK. We've got Central Virginia on the other side of the country. Rasim from New Zealand. Palm, palm bleach, as Bob Chef says in the chat there. Gideon from San Jose. Good morning. Hello from India. Hello, Francesc from Catalonia. Hello, South Africa. Checking in on the other chat feeds we've got going on here. Yeah, people are starting to trickle in on the YouTubes. Had a bit of a weird issue pushing these this morning, but it looks like everything is functional here. This is going to be a fun episode. We've been leaning harder into the education lately, and I think I'm definitely gonna learn something this episode. We're gonna be talking about some stuff that is out of my wheelhouse currently. So, bonsoir from Paris, says Albin on LinkedIn. Greetings from India, says Fatih. Hello, Lake Alfred, Florida. Hello, Tim Ebert. Hello, Rishikesh from, I'm not even going to try to pronounce that one. You got it, Satya?
Satara, Maharashtra.
Thank you. If I had a minute, I could have got it. But yes, that is a pink neon bat behind me.
Yeah.
And we're about to get started here in just a moment.
So Maharashtra is named in similar vein as Great Britain, right? Maha means great, and Rashtra means
Yeah.
country.
Okay. Wow. I see. I'm
So
already
Great
learning
Britain is
something
not the
today.
only place that calls themselves great, right?
Yeah, that's
We should
true.
have just
That's
named
true.
California Cool California. You
Cool,
just have to call
Coolifornia. Coolifornia. Yeah.
it. All right, let's get
Okay.
started.
I think now is a great time to get started. Let's go, boss.
Hello, everybody. Welcome to OpenCV Live. I'm Dr. Sasha Malik, and I'm your host, as well as the CEO of OpenCV.org. And with me today is Rupansh from Big Vision. Big Vision, as some of you may know, is also my consulting company. We do a lot of computer vision and AI consulting work. And we like educating people at the same time while we are doing our consulting work. So today we are going to talk about a technique called latent sync, which Rupansh is going to talk about. So very excited about this educational episode. But before we start, as always, this episode is produced by Phil Nelson, who is the Director of Content and Creative at OpenCV. And he produces the show. If anything goes wrong, it's his fault. Hi, Phil.
Yes, that's right. Good morning out there, everybody. It's me. It's PHILLIP. I am your co-host with the co-most, the second banana who is second to none. I'm also your plus one and only, and know that it's Mr. Nelson if you're nasty. But you, my dear friends, can call me Phil, and I'm here to remind you of a few things that we do on every single episode of this show. The first of which is a giveaway to you in the audience. In about 40 minutes through the episode here, we will be doing a giveaway for a free OpenCV University course. You can see what courses are on offer by going to opencv.org/university. We're also taking questions from you in the audience. If you're here on Zoom, use the Zoom Q&A button at the bottom of the screen. It helps us keep track of all of your interesting questions. Or if you're watching on YouTube, if you're watching on LinkedIn, if you're watching on Twitch, any of the other channels that we're on, just post your question in the chat. We will do our best to answer. It also helps us a little bit in the algorithm if you comment and subscribe and give us like thumbs ups and hearts and things like that. Speaking of subscriptions, OpenCV is now fully monetized on YouTube. That means that we have memberships for $2.99. You can go check those out. Before we get started proper, I'm going to do a little bit of a reminder. We've got a couple of awesome things coming up here in the very near future. Satya, you want to tell folks how things are going on the bin picking challenge?
Yeah, so we have worked with this company called Intrinsic, which is basically part of Google. And they are a robotics company, and we have this bin picking challenge with them. And the idea is that to grab an industrial part, the robot actually needs to figure out what is the orientation of the part, and before it can grab. So to find the orientation of the part, that's the pose estimation challenge that we are running. And we were having a hard time because we did not have legitimate submissions. People were hiding from their results because they did
That's
not
right.
want to
We
publish.
had to smoke them out.
Yeah, so we decided to have give them a small, weekly award for $200 for the leaderboard, the top on the leaderboard. And suddenly we have a few legitimate, uh, results like this.
Yeah,
So
the
we are
top
very
5 is
excited
taking
about this.
shape there.
Yeah, top 5 is looking pretty solid. Getting 0.63 map on this data set, it's not easy at all. So we are very excited about this challenge right now.
Good luck to all the teams out there participating. We've got a little more time left in this phase of the competition. In fact, we will be sending an email about the timeline to participants later today, so stay tuned. It'll also be posted in the BPC channel in the official OpenCV Slack server, as well as the official OpenCV forum. Another really awesome, super exciting, and important thing we need to talk about here today is OSCA, OpenCV's first ever in-person conference. We are pleased as punch to be partnering with Display Week. Can you tell the folks what you're looking forward to most about this, Doc?
Well, this is our first conference, so I'm really excited about it. It will be full day of talks, and we are going to bring, some really big luminaries to talk at this conference. Some of our partner companies will also give short talks. So please support us, especially people who are in the Bay Area. If you could visit us, register for this conference, it would be awesome. We are also looking for companies who can sponsor this event. We have a few sponsors already. And if you or your company can sponsor, we have sponsorships at a few different levels, $3,000, $5,000, $10,000, and $20,000. So if you are interested, please reach out to Phil at opencv.org, so that we want to make this a big success so that we can continue having this conference every year. And as it grows, we'll make it much more interesting in the future. But for now, it is going to be an awesome conference. So please, we are looking for support. I'm sounding like Bernie Sanders again.
Once again, I am asking for your support. Yes, once again, I am asking you to support open source computer vision.
Right.
We really are, though. Please go check out OSCA. I'll drop the link in all of the chats here. Of course, it's OSCCA. There are a couple of speaking slots later in the afternoon. It's a full day conference, but we've got these lightning talks we've planned for the afternoon. We're saving a couple of those for people from the OpenCV community. If you're in the Bay Area, if you make cool stuff with OpenCV, send an email to this guy. That's Phil, Phil, at opencv.org, and we can chit chat about it. Yeah. All right. I think now's a great time to get started.
All right. So Rupansh, welcome to the show. It's all yours. Please share your slides, and then we'll go over your introduction and show us what Latent Sync is all about.
Super excited about this one. I've not spent much time learning about the world of lip syncing here.
Okay, so
When you're old like me, it makes you think of Milli Vanilli, but almost everybody watching this is too young, was not even born when that happened. So, this was a big scandal many years ago in the music industry where there were a couple of
Right.
like models, a couple of model guys, like they're just, good looking dudes. And basically their producer had someone else sing for them, but lied about it. And so they ended up winning like a bunch of awards and eventually had to come clean. And it was a huge deal in like 1991 or whenever this happened. So, yeah.
Yeah, but wasn't I remember this, and wasn't that like some really tragic things happened after that? No?
Those guys' lives basically fell apart. Yeah, it was not a pleasant thing. But yeah, "Girl, You Know It's True" was their big hit.
Right.
Anyway, let's go.
yeah. So Satya, would you like to say something?
Yeah. So let me give you a little introduction as we do with all the hosts who come here. They give us a little overview of their company. So let me give you an overview about Big Vision. Big Vision is a consulting company that I run. That's what puts food on the on the table, so to speak. We do, pretty much anything related to computer vision and AI. We do work on, object recognition, detection and tracking, segmentation, document analysis, analytics, generative AI, augmented reality, pretty much anything that you can think about related to computer vision. We have done work on that. So if you have any computer vision or AI work that you need help with, please reach out to us. SP Malik, which is my email address at bigvision.ai. All right.
Okay, I think it's time for my introduction. And so, hi guys, I'm Rupansh once again. So I completed my graduation from IIT Bombay in India somewhere. And yeah, I think by now a lot of you might be curious about the picture here. So yeah, I love to play badminton. I've been playing it since a very long time. I've been playing it since sixth class actually, and yeah, I've won quite a few tournaments, and I was captain of my college team. A little bit of flexing maybe. Uh,
Right.
and then
Well,
yeah, yeah,
what
yeah.
Rupansh did not mention because he would not brag about it, but IIT is one of these top universities in India. It's Indian Institute of Technology. There are about 1.5 million people who take this exam, and I believe about 15,000 make it, something like that, some number like that, right, Rupansh?
Yeah, yeah, yeah.
Yeah.
It's a similar number. Yeah.
So yeah, about 15,000 people make it to IITs. So it's like 1% acceptance rate. Compare that to Harvard, which has an acceptance rate about 6 to 7%, right? So very competitive. So uh, that's a solid achievement. And Rupansh first did an internship with us in 2023, and recently, right after his undergrad, we hired him. We had, the summer before he did internship with us. We were blown away by, how fast he learned, right? Because when you first started, you were pretty fresh, right? I mean, and
Yeah,
you
correct,
did not
correct.
have an AI background, right? You were
Yeah,
not
yeah,
right.
yeah.
So learned a lot during the summer, and we were very impressed what Rupansh was able to achieve during that summer. And so we gave him an offer immediately, and we are glad to have him. And since the last few months, he's done amazing work, right, on a variety of projects, which we cannot go into in this talk, but you will see some of the material from one of the projects we had done, because this one is public information. The public part of that project, we decided to do a webinar about.
Yeah, actually, so when I joined Big Vision as an intern, the project that I had to do, it involved extracting textual information from, gaming cards data. So there are these collectible cards, collectible gaming cards. So in these cards, you have, a huge variety of fonts that they use, and then there are a lot of styling.
You're talking like Yu-Gi-Oh, Pokemon, this kind of thing.
Yeah,
Magic the
the
Yeah,
Gathering.
kind
baseball
of
cards,
similar cards. Yeah.
Okay.
Yeah.
baseball
Yeah. So,
collective cards. So I
Yeah.
forget the name of those things, right?
Mm-hmm.
But
yeah, so yeah, when I was given a pre-trained model which didn't perform really well on this task, and I was tasked to improve it so good that it goes up to 99% of accuracy, which is yeah, not something we were able to achieve. It's too high, but still, I mean, like over the time, I learned a lot of new things. We experimented a lot. We failed a lot, and we found success a lot. And like over time, when I saw where our model reached, so in the final stages, our model was able to detect, almost a very wide set of fonts and at all different angles and everything. So it was kind of like magic to see how you can, use all these AI techniques in order to yeah, create something so useful. So that is where I really got to know about this, really understood about the power that AI has to offer us. And yeah, I think after that, I joined Big Vision as an AI engineer. And then later, I think, yeah, I have worked on quite interesting projects in last few months. And yeah, I think we'll be talking about part of one of the projects that I have worked in. So I think I'll go ahead.
Yeah.
Yeah. So, okay. Uh, let's talk about talking. Okay. So before talking about latent sync, let's really try to understand what we are trying to solve here. So we are trying to solve the problem of lip sync here. What is lip sync? Lip sync is basically in any sort of visual content, how well the lip moves in sync with audio. That is what lip sync measures. And now, why is lip sync so important? Why is it important at all? So, if you see any sort of audiovisual content, then if you know the lip movements are not matching the audio well, for example, if there's a lag, if the lips are not moving in accordance with the audio, then it kind of distracts you from the real content that is being delivered. It kind of appears a little bit unreal. So there's this model called SyncNet, which we'll be talking about later. They referenced a paper which did a study on how lip sync affects people, how much of lip sync is noticeable by people, and they found that even 100 millisecond delay, that is, if you know the video is speaking ahead even by 100 millisecond of the audio, then we can detect it, and that kind of uh, makes the whole content a little bit off. So let's quickly see an example of this video here. Try to notice the lip, how it moves in this video.
Are you a broke beauty like me that loves to gamble but doesn't have this money? Then you have to download Cash Bash. This slot game has a super high payout.
Do you guys notice?
That audio was fantastic. Absolutely fantastic.
Okay, okay, okay. So if you would have noticed the
Are you a
yeah,
broke beauty like me that loves to gamble but doesn't have this money? Then you have to download Cash Bash.
if you notice, the lips are not closing properly,
Yeah. The
and
mouth
I
is
think that
open.
gives you away that there is. Huh?
The mouth remains quite open. If you look, if you
Yeah, 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 correct, correct. And yeah, that gives you away that it's probably a fake video, right?
right.
Yeah. Yeah. So previously I showed you an example of bad sync. The left side view is again this of the same video. Now let's see an example of a good synced video. Let's see how that.
Are you a broke beauty like me that loves to gamble but doesn't have this money? Then you have to download Cash Bash. This slot game has a super high payout.
You see, and I think this video, when compared to the previous one, the details of the tooth were much better. The sync with the audio, that was much better. And I think overall, you can easily say that if you have to choose between the left side one and the right side one, I think I'll definitely choose the right side one. Yeah. So that's kind of, you know,
Are you a
importance
broke
of
beauty like me?
Let's talk about the challenges that we face in this field. So there are many challenges that we face in this field. Like we have this problem of matching the timing. That is, in any sort of visual content. If a person is speaking, for example, if I'm introducing myself as I am Rupansh, and at the same time the audio is not matching my video, for example, when I'm saying I, if the audio is saying am, then yeah, that it's not good. And when your AI model does all sorts of predictions, so for example, if your AI model is doing this thing, then that won't be useful in real life. So that is one problem. And then there is this problem of identity preservation, which is, for example, if you have given my video as an input and you want to change the lip to match a certain different audio, then you would want the output to have same lips as mine. So I'm in context of latent sync, it just modifies the lip regions. So you want the lip to, resemble my lips. You cannot have Dwayne Johnson's lip replace mine, because I don't think that will look very good, right? So that is one problem that we face. And then visual quality. So we also don't want that the video that is generated of mine, we don't want that the video has, weird artifacts. That is, we don't want my chin to get a double chin, or maybe, one lip moving somewhere. We don't want those sort of things as well. And then we have this very universal kind of issue with all sorts of machine learning problems, machine learning models, the issue of scalability. That is, we want the model to work with, a diverse set of identities. We want it to work with a diverse set of videos. We want it to work with a diverse set of audio, and, all sorts of varieties that we can get. We don't want it to work well with only one person's videos, two person's videos, or a specific type of people's video, and things like that. So
So,
that is another.
Rupan,
Yeah.
I'd like to pause a little bit and just make sure that the audience, we are all on the same page as far as
Yeah.
the question is concerned, right? The problem that we are trying to solve, obviously we know that we are trying to solve lip sync, but here's the input. The input is an audio, right? You have an audio track and you have a video track, right? The video and the audio do not match. The video is taken from, so you have a video track of, let's say, me speaking like this, but then you would take this video, remove the audio from it, and replace the audio with a new audio. And the new audio should look like as if I'm speaking, right? So you took the rest of the video remains the same. It is only the mouth region. It is changed. And the identity, my identity would be preserved. What I'm saying changes, but the same video, approximately the same video is shown, right? So that is the output. My video with the new audio track.
Hey, boss,
but
I'll
the
be
video-
right back in like 2 minutes, okay?
Yes. All right, Rupansh, keep going.
Yeah. Okay. So let's see where we can use it. We have already understood the problem. We have saw some of the challenges that we have in this, and then where can we use it? We can all of you know that pictures are released in movies are released in multiple languages at a lot of places, and in movies there are these close-up scenes where the character speaks something, and it is a kind of a close-up scene. Then in such cases, if you're watching an English movie in, let's suppose, a different language, let's say Hindi, then in the close-up scene, if you see Tony Stark, maybe let's say we are watching Avengers in Hindi, then if you see Tony Stark speaking something in Hindi, and you clearly see that the lips they don't match well with the audio, then it kind of feels a little bit unreal. It doesn't feel too good, right? So there you can use a highly realistic, good quality lip sync technique like latent sync in order to sync the lips of the actors with respect to the local audio that you're dubbing to. So that is one use case, and I think quickly we'll see an example for this. So here in this example, the left side is a video which will be given as an input to latent sync, and it's I think it's probably Spanish or some language. I'm not so sure about it. Let's see the video.
Всем привет! Я снова рада вас видеть на своем канале, и мне безумно нравится то, что мы ведем этот прекрасный влог о моей жизни.
It's not Spanish. It's I don't know. Maybe it is Russian, but it is not Spanish.
Yeah. Oh, okay. Did it say
Всем привет! Я снова рада вас видеть на своем канале, и мне безумно нравится то, что мы ведем этот прекрасный
Anybody
влог
knows which
о
language it
моей
is?
жизни.
Okay. I probably heard Privyat in that, and it's Privyat is probably Kazakh, I think, because
Yeah,
I
it's
recently
it's
went to
from
Almaty.
right,
Yeah, I learned that it means hello.
right. All right, let's see the
So
lip sync version,
now
the dubbed version.
let's see the lip sync version. So in this lip sync version, we're using the input audio the same, input video the same as we have shown you right now, and the audio is completely different of a different person.
Are you a broke beauty like me that loves to gamble but doesn't have this money? Then you have to download Cash Bash. This slot game has a super high payout.
Yeah.
So you can see, yeah, so that was pretty dramatic. I did not even know that the original video was in a different language. And you can see that that lip sync version looked solid.
Yeah, so that's one use case where you can, yeah, I think really use it and make content more engaging for a lot of people. And then there's also these virtual avatars that are quite popular these days. I think a lot of you might have already saw some of the videos on social media. You might have saw, yeah, I think a lot of avatars. Avatars really have a very diverse set of use cases, I think. Um, you can, use avatars in order to create AI influencers. You can use them in order to, run any sort of ad campaigns for your company, for a new product, or for any sort of thing. And I think maybe this one, you can also use them in order to create a lot of educational content or any sort of I think course related content. For example, maybe for example, if Satya if Satya already has a lot of videos and audios that recorded in probably studio grade setup, and let's say he wants to record a content while he's on a vacation somewhere where he cannot access the studio setup and all. Then maybe you can utilize these really high quality really high quality visual avatars which can talk like Satya, which can move like Satya, and then which can have audio that resembles very accurately to
In fact,
Satya.
there was this ad campaign in India where, there's a top actor, like you can think about him as the Tom Cruise of India, except that he is much more popular than Tom Cruise because India has a big population.
What's
So
that?
Shah Rukh Khan. So his name is Shah Rukh Khan. He did a campaign during
Yeah.
a festival where you could make him work. You could make him have an ad for your local store, right? So imagine you're a small mom and pop store, and Shah Rukh Khan, which is like the top guy, top actor in India, he's advertising for your local store, right? And they pulled off this campaign that was that was also using lip sync, very popular. It had a lot of media attention. In fact, the people who did that campaign, we had them write a blog for us. Later, they asked us to take it down because of uh, they were so there were some issues. They did not want to. They had revealed too much in the blog of the technique that they were using, so we probably took the blog down. But we had invited them, and they had talked about this thing. Now that technology is available to everybody through latent sync.
Yeah, exactly. Yeah, even I remember seeing those ads
Yeah,
on those days. I think it was a pretty popular campaign.
yeah.
Yeah. So then let's go ahead and let's see some more use cases. So you have this
I
video
thought we
editing.
had a virtual avatar example.
Oh, yes, we did. Oh, I completely forgot this. Okay, so these two AI avatars are probably created, with first thing, the audio that they're speaking is completely AI generated, and the video itself is AI generated. They
For
probably,
Yeah,
yeah,
for people who are looking for resources for audio generation, there's this company called 11 Labs that
yeah.
produces you upload like a minute of your recorded audio, and it produces the your any then you can put in any text and it will generate audio for you. So if you are a Caucasian without speaking without an accent like me, then it nails it, right? you almost cannot tell the difference. My voice, I tried it. It does a reasonable job. I can tell that it is AI generated, but some of my friends, they said that no, it's pretty close. So interesting. Yeah, please go ahead.
Actually, even like in one of the projects, even we used an open source version to do, I think, a similar thing. I think it was fish speech, I think. And these models, they perform really well, I think.
Yeah.
Yeah, so let's see these examples of some AI avatars.
Bring your digital twin to life with HeyGen's AI video avatar. Capture your gestures, expressions, and voice once, then create limitless videos in different styles, scripts, and languages. Perfect for creators, educators, and businesses looking to scale content with a personal touch.
Do you see? Yeah. Okay. I'll play another one.
Reach global audiences without reshooting a single frame. HeyGen's AI video translation preserves your voice, lip syncs flawlessly, and converts your content into 70+ languages with 175 dialects. Speak to the world in their language.
I think.
And just so you know, we don't have any collaboration with HeyGen. It is just one of the tools that we had noticed produces reasonable results. And the lip sync is delayed because of the network. Yes, somebody said that it's actually delayed, and that is because there's something funny going on with the network.
Yeah, actually, you know what? Later on, I'll be talking about this paper called SyncNet, which is a pretty.
Reach global audience.
It's a very important paper in the context of this field that you're talking about, and the paper's main motivation was this only, that in cases like these, that is when we have to transmit audio and video data over these large networks, the audio visual sync is disturbed a bit. And SyncNet, so mainly what SyncNet was trying to do was to introduce this model which can detect this off in the sync, and it can fix it as soon as we get it.
Yeah, even when we record something, right? When we record something, especially if you're using an external mic, it is possible that the video and it is slightly out of sync, right? It is a very common problem, and it's a pain to match those things, right? And that is why people clap.
This is part of This is why they have the clappers in movie scenes. Like you need you need a source of truth, basically. You need a baseline for the audio video sync, and that's what the clapper there is for, partially. Yeah.
Right. So the clap produces a big spike, and you can just sync the hand movement to it.
Yeah, especially in the modern kind of pancake video editor stack, for example. But yeah, I mean, as a guy that's been editing video for 20+ years, I've spent so many hours of my life just fixing 50 milliseconds, 100 milliseconds of video being off from the audio. So it's still a problem to this day.
Yeah. I think I'll go ahead again.
Yeah.
I think I'm. Yeah.
Bring your digital twin to life.
Okay, so let's see, how did we get here? I mean, what techniques did people use till now in order to solve this problem, and how did they progress over time? So earlier, before machine learning entered the game, so machine learning is this really powerful tool which allows us to, which has this black box kind of thing, where you you give it a lot of data, and you have these various models and different techniques using which you make these models learn the patterns that are underlying this data. And yeah, the possibilities are a lot. But earlier, when we didn't used to have these techniques, we had to manually define the rules through which we'll map the audio and the lip movements in the video, if you want to lip sync it to a new video or something like that. So the problem with this thing is that if we try to define a fixed set of rules, then we cannot really capture all of the subtle details that that happens when we speak a language. For example, if I'm speaking, then of course there are a lot of subtle, relationship between a different type of sounds and the lip movements that are occurring with me. You cannot really capture all of these with a fixed set of rules. And yeah, earlier people tried to do this, and the results used to be a little bit stiff and in a little bit robotic. An example of this, I think, so this is a cartoon from an old cartoon. I think even I haven't saw it, but yeah, notice the lip sync here.
The most powerful man in the universe.
He-Man, yeah.
so I asked you.
I found it.
Okay, that is so funny. I when I was reviewing these slides before, I talked to Rupansh. I said that, like He-Man, and he probably did not. He's so young, he did not even know what He-Man was, and I assumed that he would know. Right?
I actually found a clip, and it actually, yeah, used. I think it uses the technique that we are talking about, and it very properly represents that. If you
The most powerful man in the universe. The most.
you see, it doesn't capture all the subtle movements of the audio, right? There are quick movements at the key moments in the audio.
Yeah, and a big part of that is because of how these inexpensive 80s cartoons were produced, is that they were running at, I think, 12 frames a second, something like that. And so
Wow.
you can't get much more smooth than that, but also it's a cost saving measure. Like, you don't want somebody drawing every single frame, man. You got to sell some toys, right? Like, let's go.
He-Man.
And
All
the
right.
Masters of the Universe. Yes. Also, there was they brought this back a couple years ago. He-Man and She-Ra, in fact, Princess of Power.
Right.
The She-Ra
But
theme song, an absolute banger, by the way. Look that shit up. It rules.
And the funny thing is that when this was televised in India, there was no closed captioning, so we did not actually know what was I still don't know, actually. I have to look it up. When he
Just that
said,
it looked
by the
cool.
power of the great, what?
No, by the power of Grayskull. By the power of Grayskull. Grayskull is like
Grayskull, right.
the castle,
I used to think that it is by the power of the great skull, right?
I like it.
Close
I like
enough.
it. Sold. Yeah.
All right, let's go.
The most powerful.
It keeps getting played again and again. Yeah, then deep learning entered the game, and CNNs and RNNs were introduced. So CNN allowed us to, really extract the detailed features from visual data, and RNNs allowed us to really learn patterns from sequence data, and they both combined together allowed us to, experiment with these audio video data sets. And then SyncNet was introduced in 2016. This is a super important paper. I'll talk about it in a bit. They introduced this concept called sync confidence score, which used to measure how well the lip movements in a video sync with audio. And now, since we got this measure of this lip sync, we had an opportunity to reduce this error, reduce this measure. Then, okay, so as I said earlier, SyncNet, why is SyncNet so important? Because in the two papers that we are going to discuss today, the two papers in the sense, Wave to Lip, which was released which was out in 2020, was the first major paper in the field of lip sync, which was able to produce really, really good results. So given a video and random audio, it was able to produce really, really good results. And the key innovation that they did was that they used SyncNet as a supervisor for the training that they have for training their GAN model. You can see this.
One important thing, as a general for people who are new to neural networks, etc. Whenever you're able to measure something, right, and clearly define that something is good or bad, like SyncNet the sync confidence score basically tells you how good the syncing is. Whenever you can come up with a loss function or something that can be measured, right? The error that can be measured, you can reduce that error using a neural network. You can think about neural networks as this optimization black box, which if you are able to define what you want to minimize or maximize, it will do it for you, right? By changing the parameters. So that's why any optimization problem, any general purpose optimization problem, can be solved using neural networks.
Yeah, correct. Yeah, so you can see this quote that I directly took from the Wave to Lip paper, and they clearly say that our core architecture can be summed up as generating accurate lip sync by learning from a well-trained lip sync expert. And by the well-trained lip sync expert, they refer to SyncNet here. Now, just to maybe give you a even better picture of how SyncNet measures this thing, I think I'll say this that. It learns the embedding. So, for example, it takes a specific length, a fixed length of video clips, and it takes a fixed length of audio clips, and then it generates embeddings from both of them. And then it calculates the distance between the video embeddings and the audio embeddings, and tries to minimize the distance for in sync pairs. That is the pairs in which the audio is taken directly from the video, and tries to maximize this distance for out of sync pairs. And through this, it is able to tell us, learning with this objective, eventually it is able to tell us what kind of audio video content is, how much in sync it is.
Right. And just to add some more color to it, this technique where you use two things, right? Two vectors. So embeddings are nothing but vectors. If you have a picture, you are to embed it into a vector space. It means that you have converted that picture somehow to a vector, right? And it could be a simple vector, 512 by 1, something like that. And similar technique is also used in captioning, image captioning. So you have an image and you have a caption for an image. You embed this text into the same length vector space. You embed this image into the same length vector space. And now you try to minimize the distance between these two vectors, right? Think about these vectors as points in a multidimensional space. And you want to minimize the distance between them. And you want to maximize the distance between unrelated pairs. So suppose there is an image and unrelated caption. You want to increase the distance between them. So this kind of learning is called contrastive learning, and it is used everywhere. You can see it in face recognition. You can imagine that you want to minimize the distance between the pictures of the same person and maximize the distance between pictures of different people. And whenever you want to align two different things, right, and maximize distance from other things, you use this idea called contrastive learning, and SyncNet is using something similar.
Yeah, I think SyncNet tries to do a similar thing there. And so one of the key things about Wave to Lip was that introduced SyncNet to the previously existing methods. And the key difference between so Wave to Lip under the hood, it has a GAN-based structure. So GAN is a generative adversarial network, and it consists of two neural networks. It consists of a generator and a discriminator. The generator produces images or the data that you have that you want it to generate from from random noise. And discriminator, on the other hand, tries to distinguish between the real data and the ones that is generated. And the training objective for GAN is that the generator continuously tries to fool the discriminator into believing that the result it's generating is real, and the discriminator tries to, accurately distinguish between the fake ones and the real ones. And I think, it's like two adversaries fighting, and hence the name adversarial. And doing this, to and fro fight kind of thing, both of the models improve, and that's how GAN is able to produce really, really good results. Just to show you a quick example, a popular example of GANs, I have this example for you. There is this site called "This Person Does Not Exist." I think it's a very popular site. So this generates images of random people that don't exist. So here are some of the examples from the site, and maybe we can just go and see a few examples for ourselves. I just wanted
Uh,
to see the
yeah, every
picture.
time you refresh this, a new
Yeah,
person's face
yeah,
appears.
100%.
Right,
Face appears. It's it's
right.
it's cool.
So GANs basically allow you to create a sample from the distribution it was trained on, right? So this GAN was trained on human faces. And so now it can generate a new sample, which is not, it is in the distribution, but it is not, this person does not exist, right? It is sampled from that distribution and it looks like a human, right? So that's what GANs do.
Yeah, it's a pretty interesting thing. And then, then came in these diffusion models. So, diffusion models, actually, stable diffusion. When stable diffusion came in, the quality of results that stable diffusion produced was even better than the ones that was produced by GANs. GANs came in 2014, and I think, they were one of the very revolutionary. Papers in the visual domain, and then again diffusion models came in and they produced even better results. So stable
Can you
diffusion, yeah,
go back one step? I just want to explain the process and then we can move forward. Yeah.
process.
So just imagine the wave to, what was the name?
Wave to lip, wave to lip.
Wave to lip. So wave to
Yeah.
lip would basically generate a picture like this, right? So there are two components to it. It would take a picture like this and or a series of pictures like this, which are part of the video, and the audio stream, right? And it would try to minimize the distance between the audio stream and pictures like this, right? And because lips syncnet is guiding the process, right? It will say that, oh, this is good, this is bad. That is why the pictures it will ultimately generate they will match up, right? That is the idea. That syncnet is looking at these pictures and the audio and trying to say it is judging whether it is good quality or not. If it is not good quality, there's a feedback loop that goes and says that generate something else which is closer to the audio, right? And that is how this mechanism works roughly. We cannot go into the details of this thing, but
No,
you get a
actually,
rough
that is
idea.
exactly what has happened actually. In the Wave to Lip paper, they mentioned that in the earlier methods that they have referenced from, they used to use, so the discriminator logic remains same as it was before, but they used to the earlier models, they used to use the simple MSE loss
Right.
for minimizing for minimizing the loss between the predicted results and the ground truth latents and ground truth images. But of course, that was not able to capture a lot of details from the lips, and Wave to Lip instead introduce syncnet loss as well with the MSE loss. As a new thing.
Right.
Yeah. Then I think then came in stable diffusion, which really changed the game. So what is stable diffusion? Stable diffusion is this DDPM based. It's a type of DDPM. DDPM stands for denoising diffusion probabilistic model, and so the key things about stable diffusion is that first it works in latent space. What is latent space? It's basically a lower dimensional representation of the image data, the data that we are trying to train stable diffusion on. And then it consists of two main processes. The first one being the diffusion process, in which it takes in an image. So you can see here the example here. It takes in an image and then it gradually adds random noise to the data over t time steps or over n time steps, and until it becomes nearly pure noise. And once it does that, the second process is the denoising process, in which the unit that is present in stable diffusion, it tries to learn the noise that is present. For example, at time step t, it tries to predict the noise that is present in the image at time step t, so that it can recover the image at time step t minus 1. So this is another process that happens in stable diffusion, and together, so if you see the difference between GANs and stable diffusion, you can, I think, one thing that you can see clearly is that GAN, a simple GAN, okay, it tries to directly predict images from noise. And on the other hand, in stable diffusion, the problem has become a little bit more simplified at the cost of more computation. You see, it gradually predicts, better and better image from a bad one. So yeah, the problem has become a little bit simpler, but at the same time, computation has increased. But then again, there are, as we are just, I think, we are just, we have just entered this era of AI, and things are moving really, really fast. We already have these distillation models, which, generate results. For example, specifically for stable diffusion, we can get as good quality results as produced in 20 steps in just 1 to 3 steps, maybe, with a lot of new distillation methods. So, yeah, it's very exciting. Um, So that was about stable diffusion and how it offers improvement over GANs previously. But then one of the difficult things about stable diffusion is that it is difficult for it to maintain temporal consistency. That is, if we are trying to generate a lip sync data, then we want it to sync well. We want it to be temporally consistent. That is, we want the lips to move inconsistent with the previous few frames. We can't have the lips abruptly change its position, because that is not what we want. And I think this is an area of exploration which is being explored, by a lot of people. And here comes latent sync. Let's see what special latent sync has to offer us. Yeah, so first of all, what is latent sync? We have already told you about it. Latent sync is a lip sync refinement model. That is, it takes in video of a person speaking, and it takes a target audio clip, which is most probably different than the one that is present in the video. And then it modifies the lip region, only the lip regions, to match the audio. This is what latent sync does. It keeps the rest of the video untouched. Maintains, fully consistent. It maintains the original video as it is. Okay, so what makes latent sync special? So as as I've already told you about the quality that stable diffusion has, the quality of results that stable diffusion has allowed us to produce. The key thing that it utilizes is, there are two things. First, it uses a stable diffusion architecture as its base in order to produce really high quality visual results. And then it uses our classic SyncNet, which was used in Wave2Lip as well, to supervise the whole training process, so that the model really syncs well with audio. It enables us, all sorts of things, the things that we discussed earlier, post dubbing, voice translation, and AI avatars. So with latent sync, we can do it with our local machines, without paying any money almost. So here, if you see this architecture, the encoder, this is the unit, this is the encoder part, the one in the blue, and then this is the decoder. this entire structure is the stable diffusion part of the model. And then this is where we utilize SyncNet in order to induce some losses, which we'll talk about in some time. And let's quickly see, another result of latent sync. So left side is the input video, which is given as an input to latent sync.
Привет, ребята! Сегодня мы играем в морской бой, и сегодня я вам расскажу, что эта игра довольно-таки непростая. В ней есть загадка, потому что
Yeah, and then let's see the lip sync version. This is, I think it's Chinese. I think I'm confident.
到面试，但是说到面试的时候，你就又特别的不想要去面试。我不知道你们有没有就是跟我有一样的焦虑感，就是跟我有这样的。
You see, I think it was I wasn't able to recognize this as a different person. I mean, the audio was different, or the person was faking it. It was a generated video. Yeah, very close. Yeah.
Привет, ребята! Сегодня
到面试，但是说到面试的时候。
Okay, let's see some of the quantitative comparisons between latent sync and the previous models that really did well. So there are a lot of metrics. I think I'll explain the metrics one by one, and we can see how the other model performed and how latent sync is performing in those. So the first one is FID, which stands for fresh ray inception distance. So what it measures is given a set of real videos and given a set of real video frames and given a set of generated video frames, it tries to learn the distribution of the real frames and the distribution of the generated frames, and then it tries to see if the distribution of generated frames is close to the real distribution or not. The lower it is, the better it is. So if you see, I think latent sync is doing pretty well in this. Latent sync is 7.22. Wave to lip used to be 12.5, and I think diff to lip is 10.3. Mu stock is better than that. Actually, mu stock and latent sync they share similar architecture. I don't remember the difference exactly, but it's also something that we have accepted.
So, yeah, one of the reasons, the reason for showing this table is that when you're trying to evaluate something as complex as lip syncing, it is not just one metric, right? You cannot rely on just one metric to say that, this is actually doing better. Because what happens is, once you try to improve one metric, it is possible that something else is falling apart, right? So you have this balancing act to make sure that all these metrics, they simultaneously improve. And that is why you look at various metrics to make sure that the quality is actually improving, right? Not just one metric.
Correct. We always want to measure a lot of different aspects of any kind of generative models, or almost any AI model, I think. So let's see. Okay, so what is FED? FED is fresh ray video distance. It is very similar to FID, except the major difference that it has is it also along with the distribution of the visual. Okay, along with the visual distribution of real data and generated data, it also calculates the temporal distribution of the data. So it takes into account the temporal distribution as well, which I think allows us to make sure that the lip movements and all sorts of movement are moving well as the time goes on. And if you see FED again, then I think in FED the results are way better for latent sync. It almost halved from wave to lip, and even from the other models, it's almost less by 100, which is I think a huge value. Yeah, so these are two different data sets that we are talking about, voxLF2 and HDTF. HDTF is I think a little higher quality data, but then again, the number of videos that this data set has is lesser. And voxLF2, on the other hand, is a little a data set with a little bit lower quality, but it has very diverse set of identities, very diverse set of video, audios, yeah, and variations in general. Then we have this SSIM, which is Structural Similarity Index. So this measures, the structural differences and intensity-based, brightness-based differences between two set of frames. So, for example, when do we try to use this one? So, for example, a very basic test for lip sync could be this: that you have a video and you have its corresponding audio, right? Then what you do is you take the video, you take its own audio, and then you give our model this audio and video to generate the results. And what we would ideally want is that the result should look exactly like the original video, right?
Right.
So here we can use this SSIM to measure how accurately the structure between these two videos is matching the structure of lips, because rest of the structure mostly it will remain similar, but the lip movements will change a lot. So yeah, we can see the differences accurately there, and also we can see these brightness differences there as well. For example, if there is artifacts or something like that, then it can also measure that. And then again, we have this LMD, which is yeah, I think like for SSIM, as I was talking about, matching the structure of the lip movements, LMD does exactly that. It tries to accurately check how close the generated videos lip sync, how close the moments of generated video is to that of the real video in cases where the audio is same as the input video. Yeah. So if you
So
see, I
landmark
think
is here. Landmark means facial landmarks, like the corners of the lips and all these facial landmarks that are detected.
yeah,
Yeah.
yeah. Here in this paper, they were mainly focusing on the lip region. And then we have this final sync confidence, which is the score that is given by SyncNet on how accurate the sync between audio and video is. And for that, yeah, you can see Latent Sync really outperforms all the previous models.
Right.
And actually, Wave to Lip also does really well in this, because Wave to Lip was also trained using this.
Yeah.
So that does well in this. Let's quickly see an example of how the result of different models have changed over time. This one is from Wave to Lip, the first breakthrough in lip sync.
Oh, you know what? I've had so many friends in and out of the.
So if you see,
Oh, you know what? I've had
the
so
lip sync
many
is really good,
friends
but
in and out of the.
the issue that Wave to Lip faces is in maintaining the identity, maintaining the visual quality. It introduces these artifacts in the videos. That was one drawback.
Oh, you know what? I've had so many friends in and out of the.
So in this video, if you notice, by the end of the
Oh,
video,
you know what? I've had
the lip,
so many
this region,
friends in and out of the.
yeah, there's a sudden jump in this region. So that was again issue of good visual maintaining a good visual quality over time. And all of this was eventually, a lot of these were fixed really well in Latent Sync. If you see the result,
Oh,
we've already seen quite a few. Let's see another one.
Oh, you know what? I've had so many friends in and out of the.
You see, I mean, yeah, it the lag is really less, and then the visual quality of the lip region that is also maintained really well. Yeah.
Right. So should we take a quick break, and for the question for the.
Yeah, sure.
Yeah, let's do that. Go ahead and do me a favor, unshare your screen there if you don't mind.
Okay. Gotcha.
Fantastic. Yes, hey there, everybody. So now is the time in the show where we do two things. One, we remind you that OpenCV is a nonprofit organization that creates an open source computer vision library that anybody can use absolutely free. That means we depend on the support of companies and people just like you. I'm going to share our screen a little bit here and talk a bit about OpenCV and what you can do to support OpenCV, and then we're going to do our trivia giveaway. One of the things you can do is join OpenCV University. This episode is brought to you by OpenCVU and, of course, Big Vision. You can go there to find a couple of free courses. Doc, you want to give them a couple sentences about OpenCVU?
Yeah, so OpenCV University, we are on a mission to train the global workforce in AI. So if you're thinking about switching your career to computer vision and AI, we have the ideal set of courses, and you can go to OpenCV University, check them out. Buy the complete bundle, which is computer vision and deep learning master's program, which will give you access to all our programs. Including fundamentals of computer vision and image processing, and deep learning with PyTorch, and deep learning with TensorFlow and Keras. So these are foundational courses that can help you start a career in AI.
Yes, indeed. And not only that, OpenCV has a t-shirt and apparel shop here. You can go to opencv.myspreadshop.com, get the iconic import CV2 shirt. Or a hoodie or a hat or what have you. We've also got the beloved OpenCV logo on various sorts of apparel, buttons, bags, and of course, suitable things for adorning your pet, small child, or whatnot with, as well as the I Love OpenCV shirt in English, in Espanol, and in simplified Chinese. You can also support OpenCV by becoming a sponsor on GitHub. We've got 16 sponsors on there this week. Thanks everybody for throwing down your cash over on GitHub. A quick shout out to IODevel, I guess, or LoDevel Ecosystems. We've got Runjia Lee, DJ Greenwood, Ruda's Laboratories, Tala Hussein, Varodo, RoboFlow, the homies at RoboFlow, Alexander Ismailov, Comet ML, Jonas Heinle, looks like, Nick Libertini, Blue Jay, Jesus Anaya. We've got a couple new ones here. Kidev, I think is the username there, and Victor Vedovato. Thanks so much, everybody, over on the GitHub. You can get there by going to github.com/sponsor/OpenCV, and you will be almost as cool as these people. We also have matching donations from a company called Benevity. If you work for a large company like an Apple or a Google or whatnot, it's very possible that they will do matching donations. So if you give OpenCV some money and you tell your boss about it, we might get the same amount of money from your company. It also counts in some places if you do work. If you want to contribute some hours of your time to write code for OpenCV, sometimes your company will match that in money as well. You can also just give us money via credit card, via PayPal. And if your company benefits greatly from OpenCV, consider becoming an OpenCV member organization. There are many benefits from OpenCV for OpenCV members, including appearances on this very webinar, as well as being represented at OpenCV's in-person events, such as the OpenCV SID Conference on Computer Vision and AI, aka OSCA. Yes, you can also, we'd also like to thank our existing members and partners. We really could not do this without you, and we appreciate you so much. We're going to, I think, maybe add a few of these in the coming months or the coming weeks as we lead up to the big OSCA event. And of course, you can now become an OpenCV YouTube member for just $2.99. You can come over to the YouTube side of the fence and use the OpenCV logo as an emoji. You get a little badge on your profile showing that you're a supporter of OpenCV. We've got 4 of those supporters right now, and we really do appreciate it. Now, comes the time you've all been waiting for, the giveaway. This week's giveaway is an OpenCV University course of the winner's choosing. Now, the way this works is I'm going to ask you a question, and the first person to answer that question correctly in the Zoom chat with their messages set to everybody will win the OpenCV course of their choosing. You can see what courses are on offer by going to opencv.org/university. So, earlier on, we discussed the huge event coming for OpenCV next month. What day is that event? What day does OSCA take place on? Come on, folks. Help me out here. Oh, they're all looking up the website now. Oh, man. We need to start repeating. So close, Venkatesh. We need to start repeating the date more, Satya.
Right.
Nope, you're just off, guys. Come on. We looked at the website earlier. You're really disappointing me here.
And people did not,
Hey, there we
right.
go. All right, Aaron Masuba. Aaron, congrats. The date we were looking for is May 12, 2025, for the first official in-person OpenCV conference here in the Bay Area, San Jose, California. Congratulations to Aaron. Aaron, please send one email to me. That's phil@opencv.org. Check out the courses available at OpenCV University. Pick one of them, tell me about it, and now it becomes yours. Congrats, and thanks for watching. With that, I think let's continue. Let's finish up this presentation, shall we?
Yeah. I'll share my screen again.
Yeah.
Okay. It's visible, right? All good?
Looks good.
Let's go.
Oh, you know. Oh.
Okay. So finally we are here. Try it yourself. So if you have a GPU which has 6.5 GB of memory, then I think you can run the setup on your local machine as well. So
Which I think these days is the majority of GPUs, right? Like you're not going to have less than 8 gigs usually, right? I think it fits in there
if
now.
you have it,
Yeah.
I think you'll definitely have this much at
Right,
least.
but I don't know whether it will work that smoothly on a Mac, right? So if you don't have, because I mean, Macs don't use NVIDIA GPU, so it might start using the CPU. I'm not 100% sure.
Yeah.
Generally, they're pretty speedy on this stuff because yes,
Okay.
it's shared addressed RAM
okay.
basically for all that.
Actually,
So yeah.
I think it'll work because I do know that Stable Diffusion works on Mac,
No,
and
it works, but doesn't it use the CPU?
It's a little bit of both, but it's
I
pretty
think so, yeah.
fast actually.
Okay.
Yeah, I think. So I'll quickly tell you about this Gradio. Gradio is a Python library which allows us to create these web interfaces for machine learning models really quickly, and yeah, it's pretty great. You can create uploading. You can create interfaces where you can upload video, audio, record audio, and maybe add sliders for different parameters and everything really quickly. So that is what radio is, and good for us that Latent Sync readily has a radio app that we can run once we have cloned the repository first using this command, and then once we have installed all the dependencies, we can directly run this command in order to get our radio app up and running. And yeah, it takes around 6.5 GB of GPU memory to run. So let's see the interface. So this is how the interface looks like. I think I have Gradio app demo deployed. It allows us to deploy it on a public endpoint, so anyone can access it. Can I? Yes, I can. Okay. So it looks like this. You can drop a video here, and you can drop a audio here, and then maybe play around with these parameter values here. So for example, guidance scale. If you increase this value, then you get better lip sync, but at the same time, you might have a little bit, reduced visual quality. But then again, Yeah, it's a trade-off, and I think the default value works pretty well. So you can play with it a little bit more. And then inference steps. We have already talked earlier about inference steps in stable diffusion. So as you keep on increasing the number of steps, the results keep on getting better and better. But they get better at the cost of computation. So yeah.
How much time does it take for, let's say, a 10-second clip?
For a 10-second clip, okay, so there's this lot of pre-processing that it does, but otherwise, on a 3080 Ti, I think it for a 10-second clip, it takes around 7 to 8 seconds. I don't have the exact number, but
Okay.
yeah, it takes around 7 to 8 seconds to
That's pretty damn fast.
Yeah, it's pretty damn
So
fast. So if you
basically, there is one-time pre-processing that it does.
yeah, correct. And
And
that
then,
takes a lot of time.
right, that could take a long time. But after that, if you want to change the audio, if you want to give a new audio or things like that, then that piece is relatively fast, right? A few seconds.
Correct.
Okay.
Yeah, it's pretty fast. Yeah, so quickly, maybe I'll just use a default example that is present here, just to get the inputs ready. So this is the input video that we have, and an audio. Is it ready? I think it's getting uploaded. Okay, I think it's ready. And then you can just hit this process video, and the processing starts here. You can see it'll take around 230 seconds, but most of the time of it will go in, processing the video.
Right.
Yeah, so till this runs, let's continue our presentation. So this you can use on your own system if you want, and then let's see how the training pipeline of latent sync. Let's see how latent sync exactly learn what it learns. So latent sync has this two-stage training process. The first stage is a place where all the parameters of the unit of the stable unit that is there in the stable diffusion, all the parameters of this unit are unfreezed, that is, they are being trained. And in the first stage, the objective is very simple. We are just trying to we're just trying to minimize the MSE loss on the noise that our unit is predicting. It's as simple as that. We just want the model to visually at least reconstruct what it is seeing, get as close to it as it can, because it's not just the lip syncing part, but actually, so the input, if you see, that goes into our unit or into the stable diffusion architecture is this masked frame. So there is this mask. So our architecture has to first, learn how to recreate all the details that are covered by this mask. So in the first stage, the main task is this, that it learns how to produce visual features really well, and I think it starts to generate lip sync well as well.
Yeah. So it is trying to predict the original reference frame from the mask frame. Is that correct?
No. No? It's not trying to predict the original mask frame. It is trying to predict our target frame only.
No. I meant it is trying to produce the original frame given the mask frame.
Yeah, correct.
Okay.
Mask frame and the reference frames.
Yeah. Okay.
Okay, so I'll just quickly go through the architecture. So we have these mask frames. So we have the input video from which we extract the reference frames, and then we apply a fixed mask to all these frames. And that is how we create these masked frames. And then, this goes into the encoder, which is not being trained. And we have latents for these. And then we have original latents. And by that, what I mean is, so for the same video, we take, a part of the clip, which is different from this one. So for example, if we have a 10-second video, then we take 16 frames from the first half and maybe 16 frames from the second half. And that we define as, the ground truth frames. That are the ground truth frames. And the audio is taken again from the same 16 frames that we have taken as our ground truth. So we have, these three things. And then we add noise to the ground truth latents. And we have these audio embeddings for this for the audio. And so the input to the unit is concatenation of the noise latents, the masked frame latents, the reference latents. These go as input to the unit, and the audio embeddings, they go as an input to the cross attention layers of the unit. They go as keys and values to the cross attention layers of the unit. And these visual latents that we have, they go as queries. And yeah, internally, it utilizes this cross attention in order to really guide the visual generation to sync with audio. So yeah, this is the main architecture. And then once we have the noises from the unit, which is basically trying to predict the noise that we have added to the latents, to the original ground truth latents initially. Once we have this, the first stage is trying to minimize an MSE loss between these two. That is the first stage. And then, so here the unit learns, the deep layers in the unit, they learn how to produce the visual features really well. And then in the second stage, what we do is we add some motion modules, which are, some kind of attention modules again for maintaining temporal consistency. And we freeze majority of unit layers. We just keep the attention layers and the motion modules unfreezed. And then we continue our training with more advanced losses, such as we introduce LP-IPS loss, which is a loss between deep visual features extracted from ground truth videos and the targeted videos and the generated videos. So we have visual quality loss like that, and then we have our key ingredient, the sync-net loss, that makes sure that the the video is really in sync with audio. And we also have an additional loss to maintain temporal consistency. So we introduce these loss, and we keep the unit freezed, the majority of unit freezed for the second stage of training. And this offers multiple benefits. First is that a lot of parameters of the unit has already been learned in the first stage. So in second stage, you freeze a lot of them. So you don't have to, you reduce a lot of, I think, GPU requirements in the second stage. And yeah, you make the model focus on more detailed features, such as the detail in the tooth, the tongue movements, and all those sorts of details. Yeah. So if you want to run this training, then either the stage 1 training or stage 2 training, then it's very simple to do. You just have to change the config. You just have to change the config file path and run this command, train unit.sh from the original repo. And the amazing thing about this latent sync is that the second stage training with the optimized version that they have released, just I think it was on 14th March that they released this, you can run it just with 20 GB of GPU memory. And yeah, I think that's really great. And okay, so why is this a really big deal? Because latent sync already performs well, on a diverse set of identities, and it already performs well with English. It already performs well with Chinese, and I do remember seeing, a lot of data from other languages as well. But for example, if you want to run it on a local language, for example, if you want to run it on Telugu or some other local language in your country, then I think latent sync will have trouble syncing with it really well. So what can you do about it? You can just collect some data of the local language, and then you can fine tune latent sync using the second stage training, because yeah, that's what the author recommend in order to learn any new language. And I think yeah, even we have experimented that, and it learns really fast. So you can just run the stage 2 training for maybe 2-3 days or 1 day, depending on the resources that you have, and you have a model that is adapted to a whole new language.
Right, right. So for most people, right, who are trying to use it for English, you do not need any training. You can simply use what Rupansh has already shown. We'll go back to that screen. But for most of the time, like I would say 90% of the time, you will not need any training. But if you need to, right, for your own language or for specific reasons, you can do it using this the script that they have provided. Yeah. Okay.
Yeah. And there
Can we
was
go back to that
the
over?
results. Yes, yes. I think we should have a look at them. I think they should be ready. Okay. Do we have it? Yes, we have it.
Okay.
I think I'll minimize your screen. Okay. I play it from here.
Okay, that's better.
The video is not running.
Maybe try scrubbing the timeline. Sometimes that'll unstick it.
Okay. Yeah, it is.
At least it's there. We could see some movement.
Okay. It's stuck. Okay. It's
Okay,
stuck, but okay.
The
maybe
brave
again.
live
I
demo
did.
strikes again.
Okay,
Hey,
it's
nice.
working.
Okay, so we don't have the audio, but you can see at least the quality of lips that it has generated. Yeah, actually, I've already saw the video and it syncs really well with audio. So you can just focus on the lip quality. Okay,
Yeah,
that's
and I mean
great.
he's moving around a lot too. Like this was a particularly difficult video, I would say. This guy tilts his head, it's
Right.
Yeah.
Well, so they, I'm assuming that they do facial landmark detection, bring all the face to a canonical position, and then the lip syncing is done in this, and then they return the face back. Rupansh, can you verify what I just made up is true or not?
Well, I mean, it's difficult. Then again, it uses audio in its cross attention layers to guide the whole
No,
imaging process.
what I wanted to say is because the mask you had mentioned that the mask is a fixed mask, right? Which means that they
Yeah,
must be moving the face to a canonical
Okay,
position,
okay.
right?
Yes,
And
yes,
then
yes. Okay. Yes, yes.
okay,
Yeah, that's the pre-processing part that I was talking about. So it basically, detects all these facial landmarks, as you said, and then it crops that region and fine transforms it so that it has a standard structure where it can come. Yeah.
okay,
And then it again stitches it back to
right,
whatever
right.
you need. Yes,
Yeah,
yes, yes.
that's what I was expecting.
Exactly. Yes. Yeah, so that was about latent sync and this whole field about lip sync. I think I hope you all were able to see how we started with rule-based lip syncing and how far we have come with latent sync. I think you guys might have you saw the results and you saw how realistic the results were. When I saw them first, I was really amazed because I was working on a similar project a while back, and that was not too much early. I think it was 3-4 months back, and even then we didn't see a model which was as good. So yeah, it's really amazing. So the key things about latent sync is that it builds on stable diffusion, which allows it to generate results which really have very good visual quality, and then it utilizes SyncNet in order to get a really good sync with audio. And the great thing about latent sync is that if you want to adapt it for a new language, a completely new language, completely local language, then you can do it with a lot less resources. So it's amazing. And because it offers because I think the results look like quite good, you can use it in the applications that we have talked about earlier, like the dubbing example, the voice translation and content creation and all. Yeah. No, thank
Awesome.
you. Yeah.
Right, we went a little over, but it was worth it.
Yeah.
I think this technology is pretty solid. People should try it out, and I think it will be. You'll be amazed. You start fooling around with these models, you'll see how good these are getting every day. It's scary also because now you can make anybody talk
Yeah.
anything. right?
Yeah.
So you remember a while back there was this Obama video, which was a voice artist was actually speaking on behalf of Obama, and then they had Obama speak these things that he actually had not spoken, right? And it was very clear. I mean, he mentioned that because the video had the original voice artist also right there. So, but now that required some professional. It was in a professional setting, right? Those I think New York Times or somebody did that, and professionals were involved there. Now anybody, right? You may not even know anything about much about computer vision or AI. You could just use this tool to produce something which is very compelling. So both scary and promising.
Yeah, it's as they say, may you live in interesting times. These are certainly interesting times. Speaking of interesting times, our guest next week will be the great fellow YouTuber Murtaza Hassan. Murtaza will be joining us with I'm told a very impressive announcement. I guess I don't think we're allowed to talk about it yet,
No,
but I'm looking
not yet.
forward to it.
Yeah, not yet.
It's gonna be a fun one. Join us the same time here, same bat time, same bat channel, 9 a.m. next Thursday for that. Doc, you want to take us home?
Yeah, thank you so much, Shrupansh, and a very good presentation. We learned a lot. Thank you, Phil, for organizing this show, and thanks everybody for joining us every week. We really appreciate that. That's about it. Thank you so much.
Yeah, I really hope people can use the things that we learned today somewhere. They can find some use case where they can utilize it in sync, maybe.
Yeah. Thanks again, Rupach. Thank you for watching. Take care of yourselves out there, folks, and take care of someone else if you can. It's needed now more than ever. We will catch you next time. Adios.
All right.